Hello, Hodghill students. So today we are looking at the topic of relative frequency, um, which is the beginning really of probability. We're going to move on later in the week to look at Venn diagrams and probability there. The lesson objective today is to be able to work out probability using relative frequency. To access this lesson, you're going to need the following equipment: a pen, pencil, a piece of paper, and a ruler, potentially to draw some tables. Okay. So the first thing really is to just touch on the difference or the basic understanding really around theoretical versus experimental probability. Now, the best example I can give you of this is flipping a coin. So the theory would suggest if I flip a coin twice, I should get one heads and one tails, because the theory is that you've got a 50-50 chance of getting heads or tails, so it's a half-half chance. So if I get heads the first time, theoretically I should get tails the second time, okay? Because out of every two flips of the coin, I should get a heads and a tails, a heads and a tails, a heads and a tails. That's what the theory says. However, experimental probability is actually doing that test. Now I have a coin here in front of me. So if I flip this once, here I go, I'm flipping my coin. I got heads the first time. I'm now going to flip it again. And what do you know, I got heads the second time. So what does that mean? Does that mean that actually all the theory is wrong and every time you flip a coin you got 100% chance of getting heads? No, of course it doesn't, but the experiment so far suggests that. Theoretical probability versus experimental probability, really we're talking about what are we expecting to happen and then what actually happens. Okay, so the experiment would be me actually flipping the coin. And as you can see from my example just now, according to this two flips I just did, it's 100% likely you're going to get heads. If I flip it again, I got heads again, so it's still 100% likely. I've got a 3 out of 3 heads so far. Now, obviously, as you should all know, that doesn't mean that every time you flip a coin you're going to get heads, but that is the experiment. That's what the experiment suggests. Next, relative frequency is basically you using the data that you've got, using the results of your experiment to predict what's going to happen in the future. So best way for us to think about this would be a simple example. So let's say I want to find out how many people in a huge football stadium with, I don't know, capacity of 80,000 people, I want to find out how many of them are under 20 years old. Now to do this I can conduct an experiment. What I'm going to do as my experiment is I'm going to ask 10 people. And this is the results. These are the results. Now, what does this mean when it comes to relative frequency? Well, what this means, back to my sort of question, how many of them are under 20? Well, I've got this person's under 20, this person's under 20, and this person's under 20. So I've got 3 out of the 10 are under 20. So I'm going to put 3 out of 10, which you'll know is 0.3, or if I want it as a percentage, 30%. So what I've just worked out then is the relative frequency of under 20-year-olds. The relative frequency is 0.3. In other words, if I expand that out then to my whole population of 80,000 in the stadium, I can estimate there's 30% of the people in the stadium are under the age of 20. Okay, next. Here is another example. This time I surveyed 200 students to find out how many of them were vegetarian. These are the results I got. 28 of them said they're vegetarians. The rest of them are not. The rest of them eat meat. So that means there's a 14% So that means there's a 14% chance that if I pick somebody at random, I'll get a vegetarian person. Now, obviously, there aren't 200 people in the school. There are actually, I mean, in our school, for example, there's something like 1,500 people, approximately. 1,500 students. So if I scale that up, I would still predict 14%, but 14% of 200, well, that's 28. 14% of 1,500 is a bigger number. So I could estimate how many vegetarians there are in the school, for example, by taking my relative frequency from my sample of 200, and I expand that, sort of apply that to a bigger sample. So 2,000 pupils or 10,000 pupils or whatever it might be. And that's a key point. Okay, I want you to write that down on the piece of paper you're working on at the moment. So write down, the more people that are asked, the more accurate the relative frequency becomes. And that is generally true of any kind of experiment. The more times you do something, the more times you can verify the results. So the more people I ask, the more accurate my relative frequency is. Here's another example, which I'll go through now myself. Fred records the colour of 100 cars that pass by his house. Here are the results. So he's sitting outside, sitting in his room, looking outside the window, watching what colour the cars are, because obviously it's COVID times and we've got nothing better to do than just sit and look out the window. So there are 10 red cars, 15 blue, 38 silver, 32 black, 5 other. Altogether that is 100. So let's first work out our fractions. So the fractions would be 10 out of 100, 15 out of 100, and so on. Calculate the relative frequency, or experimental probability, it's the same thing, so the relative frequency of each colour. So you can turn that into a decimal, and there's your answer really. 0.1, 0.15, 0.38, 0.32, and 0.05. So I've worked out my relative frequencies. Question 2. What is the probability that the next car to pass the house will be red? Now, based on this experiment, based on this relative frequency right here, I'm looking at the red, I've got a 10 out of 100 chance. Or if I simplify that, that is 0.1 or 1 out of 100. What's the probability of me seeing a blue car next? Well, that would be 0.15 or 15 out of 100. What's the probability that the car is not black? So that is anything except for this. So that, or that, or that, or that. What this means is you have to add together these 4 numbers. That gives me a probability of 0.68, or 68%. Final question then. What, on an average day, 3,500 cars pass by the house. Based on the results that I've got here, how many of these would we expect to be silver? Well, looking at my relative probability for silver, which is 0.38, what's the probability that... Sorry, how many of these cars am I expecting to be silver? 0.38 means 38%. So what we're going to do is take 38% of 3,500. That gives us 1,330 cars is what I'd expect to be silver. Just a quick reminder, you should already know this, for mutually exclusive events, which is a posh way of basically saying you can't get more than one of the different outcomes. So for example, heads and tails, half and half, you can't get heads and tails at the same time. You can either get heads or you can get tails. That means they're mutually exclusive. You can't get them both at the same time. The probabilities will add up to 1. So there's a half chance of heads and there's a half chance of tails. Half add half equals 1. Here is another example. A bag contains some sweets. The flavours are either strawberry, chocolate, mint or orange. So they are mutually exclusive. Those are the only flavours in the bag, and you can't get one sweet that's got both. So strawberry, chocolate, mint or orange. Work out the probability that Sarah will take a chocolate sweet. Well, based on what's written up here in red, I know that this has to add up to 1 altogether. So this missing bit has got to be 0.31 because that makes it add up to 1. And then finally, the bag has got 200 sweets in it. How many mint sweets are there in the bag? Well, if the relative frequency is 0.17, then I need to do 0.17 times 200, which is 34. Here is a question for you to try. I'm going to ask you to pause the video now, work out the answer, and I'll reveal it in a second. Okay, answer is 0.2. The reason that the answer is 0.2 is because these 4 boxes have to add up to make 1. Because it says 4 teams are playing to win the cup. Only one of them can win. So one of these teams has to win. What's the probability it's United? Well, it's 0.2 because one of them have to win. It's got to add up to 1 or 100% because one of these teams is going to win. I know this one does say teacher example, but I'm going to give you a chance actually to try it yourself before I go through it. So pause the video now, have a go, and then I will go through it afterwards. Do that now, please. Okay, so the answer to this question is, part A at least, is very straightforward. You know it adds up to make 1 because reading the question, the bag contains counters which are blue, red, green or yellow. There's no other colours, so I'm not missing any data here. It's going to add up to 1, so it has to be 0.4 because that makes 1 now. For the second part of the question, Mark puts the counter back, so the one that he took out goes back in. Laura takes a counter from the bag. She looks at the colour, then she puts it back, and she does that 50 times. Work out an estimate for the number of times she takes a red counter. Well, there's a 20% chance, or a 0.2 relative frequency, of getting red. So 0.2 times 50 gives me 10. So the chances, or the estimate is, she'll take 10 red counters out when she does this 50 times. Right then, I would like you please to do, if you're in set 1, I want you to do all 3 of these questions. If you are in set 2, then I want you to do the first 2. So that's question 2 and 3, or the red and the amber questions, okay? As always, take a picture of your answers, upload these onto class charts to complete today's remote learning. Good luck with that. Thank you very much.